Welcome back. Today we are on page 44 in your packet. If you don't have it, go grab it. It's important that you write these notes down. So the first part of this topic, we'll take a little break from proofs and just focus on isosceles triangles. And then we'll try a couple proofs with them. I could very well break this into a couple videos, but we'll see. So what is an isosceles triangle? It has two congruent sides and two congruent angles. All right, so here's an example right below. Let's talk about the parts. The two congruent sides are called the legs, and you see them marked with these symbols, so those are legs. All right, the third side is called the base, and it's not necessarily on the bottom. The angle opposite the base is called the vertex, so up top here. And the angles opposite the congruent sides are called base angles, and those are also congruent. So if I were to draw a line to the angle across from this side, this is a base angle, and this is a base angle, and they are congruent. So the sides that are equal are across from the angles that are equal. All right, so isosceles triangle theorem, this is what we're going to use in our proofs. If two sides of a triangle are congruent, then the angles opposite the sides are also congruent. So again, since RT is congruent to RS, that means that angle T is congruent to angle S. And that's the isosceles triangle theorem, or definition of an isosceles triangle. The converse is true as well. All right, so if the base angles of a triangle are congruent, then the sides opposite those angles are congruent. So again, if I say angle N is congruent to angle M, if you were to follow it across, side LM is congruent to side LN. Okay? All right, so we'll use those later on in the proofs. And again, we can just say definition of an isosceles triangle, or you can, write it out. But let's first use this information. So it says to find the measure of angle E. Well, if you notice, this side's congruent to this side, so the angles opposite them are congruent. So angle D is congruent to angle E. So we can say 5x equals 3x plus 14 right over here. Solve it. Subtract 3x from both sides. 2x equals 14. Divide by 2. X equals 7. But then we have to find the measure of angle E. So the measure of angle E is 3 times x plus 14. All right, well, x is 7. 3 times 7 plus 14. 21 plus 14 is 35 degrees. All right. Find each angle measure. Again, 78 your vertex. These are the same, so that means that this side and this side are the same. So if you don't know something, just call it x. So if we add up those sides, we have 2x plus 78 equals 180. That's how many degrees are in a triangle. Subtract the 78. And divide by 2. So the measure of angle C and A are both 51 degrees. Now, did you have to set up an equation? No. Some people just subtract the 78 and divide by 2, but it's exactly what we're doing in our equation. All right, same thing here. Those are our two base angles. I can tell because they're across from those two congruent sides. It doesn't matter that they're not on the bottom, okay? It all depends on where the sides are. So 2x plus 86 equals 180. Subtract the 86 from both sides, so 2x equals 94. And then divide by 2. And each angle is going to be 47 degrees. Okay. Same is true if they're variables, just like that first example we did. So 8x is the same as 6x plus 18. Because again, those are the base angles there across from those two sides. So we'll subtract 6x. 2x equals 18. So x equals 9. If I want to find the measure of angle H, I'm going to do 8 times x, which is 9, 72 degrees. Okay. And the last one, 2x equals x plus 30. This is an easy one. Subtract x, we're left with x equals 30. So if I want to find the measure of angle M, 30 plus 30 is 60 degrees, which would make this 60 degrees and this 60 degrees. So we're dealing with an acute equiangular triangle. All right, so let's see what it looks like in a proof. So this just wants us to prove that angle BAD, we're not doing a full triangle proof, angle BAD is the same as angle BCD. All right, that's what we're trying to prove. That's going to be our last statement. So let's see what we have here. It says isosceles triangle ABC and isosceles triangle ADC. It has the sides marked. All right, so what you can say, if you ever see two sides that are the same, the base angles, which I'm going to call angle 1 and angle 2, are congruent. And if you look at the other triangle, going the other way, angle 3 is congruent to angle 4. So basically you have two triangles butted up to each other, and their base angles are right there. So angle 3 is congruent to angle 4. Again, make sure you use those numbers. And how do we know that base angles in an isosceles triangle are congruent? Or you can say definition of isosceles. Couple options there. Okay, so now we're trying to prove the whole angle. We know that the parts are the same, so what if we add these together? So if I take angle 1 plus angle 4, it's the same as taking angle 2 plus angle 3. And that's just addition postulate, or just addition. And what you're left with are those full angles. So there's your last statement. Angle BAD is congruent to angle BCD by simplifying. And that's it. Nice quick proof. All right, let's see what it looks like when we add in a little angle side angle stuff. All right. So it says prove triangle ADM. So let's see what we're working with. ADM. So we want to prove this triangle is congruent to BEM. That's what we're trying to prove. All right. So I just lightly shaded in. I know mine's not very light, but it's okay. We'll go with it. I'll change up my colors. Okay. So it says isosceles triangle ABC with CA being congruent to CB. Since there's a couple of things going on, CA is congruent to CB. That whole side's congruent to that whole side. So since that's an isosceles triangle, think about an isosceles triangle. If I tell you these are the same, these are the same. So angle A is congruent to angle B. That's going to be my first statement. And the reason, definition of isosceles triangle. All right, so we have an angle in our little triangles. M is the midpoint of AB. Okay, well, AB is being cut in half. So AM is congruent to BM. So now we have an angle and a side of our two little triangles. We're off to a good start. The reason we knew that, definition of midpoint. So so far we've used the two statements as reasons, not just a coincidence. All right, and AD is congruent to BE. Wow. AD is congruent to BE. So we have our side angle side. We are done. So triangle ADM is congruent to triangle BEM by side angle side. So that looked like it was going to be a tricky question with that overlapping triangle. But it wasn't bad. You just got to look at what you have. Definition of isosceles comes in handy. This one we're going to do in class because there's about 14 steps. So we'll save that. All right, let's see where we're at with time. Oh, we're good. Okay, so let's get this, pause your video, get your statements and reasons set up for me. Okay, so again, pause the video if you haven't done this already. Write down your statements and reasons telling us to prove angle B is congruent to angle D. So again, if you haven't, pause it quick. Okay, so AB is congruent to CD. All right, so we have a side. BC is congruent to DA. We have another side. Awesome. We want to prove angle B is congruent to angle D. It didn't tell us that. It wants us to prove that. Well, if you prove the two triangles are the same, then any parts are the same. So we're going back to a CPCTC. Now think about the ways to prove a triangle. Side, side, side being one of them. I don't have any angle information, but I have the reflexive property telling me that this shared side is the same. So AC is congruent to AC by the reflexive property. We only have 2 steps left. The triangles are congruent by side, side, side. All right, so it's up to you how you want to start it. I'm going to say triangle ACD is congruent to triangle. Now be careful. A matches C. All right, so it's going to be CAB. A little different. By side, side, side. So that means angle B is congruent to angle D by CPCTC. And what does that stand for? Corresponding parts of congruent triangles are congruent. And that will be a question for you. Okay. I think I will save this last proof for class, but if you would like to give it a try, it's not a bad idea. I already got your givens in there, but we'll talk about this one in class. Give it a try if you want. And then tomorrow in class, we're going to be practicing on pages 48, 49, and 50. And that's pretty much it for the unit. We're going to have another quiz. We'll do some practice, and we are set. All right, have a great day. Stop by the math lab if you have questions.